But there are still some engine manufacturers that can still pass the emissions without the electronic injectors.
What's the difference between a regular mechanical and a common rail engine?
What's that?
What's the difference between a regular mechanical injector system and a common rail?
Well, a common rail has a computer that's controlling the injectors. On a mechanical, it's receiving fuel pressure from an injection pump. Now, this injection pump sits on a camshaft. And what a camshaft is a shaft with cams on it. What's a cam? Reader's Digest version of a cam. A cam is a bump. So it's a shaft with bumps on it. And every time that bump comes around, it pushes on something. And in this case, it's going to push up on this roller here, which there's going to be a measured amount of fuel sitting in what we call the plunger. And then when this gets pushed up, that measured amount of fuel pushes through that tiny little hole, and that's when the fuel pressure gets driven up, and that measured amount of fuel goes to the injector, and the injector sprays that into the cylinder. On an electronic engine, there's a single rail, which each injector is tapped into that rail. And that single rail is pressurized at the same pressure. So that's at 20 to 60,000 PSI, always on that rail when the engine's running. Now, each injector has electric solenoids on it, which the computer is telling to open and close. And I can't tell you how it can operate that quickly. If you do the math, it's pretty amazing. So a mechanical engine like this sprays once per power stroke. An electronic engine can spray up to 7 times on each power stroke. So how it can get that little device moving that quickly is pretty impressive. And it lasts as long as it lasts. It's pretty impressive technology. All right. So surface area. So let's imagine I have a fire pit here in the front of the room. And say I cut a log that's 18 inches long, 5 inches in diameter. I put that log in the fire pit. I light that log on fire. What part of that log's burning? The outside. Why? Because only the outside of the log has oxygen in contact with it. The inside of that log might be hot enough to burn, but there's no oxygen there. And so that's going to give off a certain amount of flame and heat, which we can measure in BTUs, British thermal units. And so we get that specific measurement. Now, if I take that same log and I split it into 5 pieces, and I put that in the fire pit and I light that on fire, I'm going to have more flame and more heat coming off that same amount of fuel, right? And if I took those 5 pieces and I ran that through a wood chipper, put that in the fire pit, I'd have even more flame and heat. Now, if I took those wood chips and I turned that into sawdust and I lit that on fire, I'd get a quick with the sawdust and a lot of heat very quickly. So we're trying to get the sawdust out of our injectors and not the log. So surface area matters. All right, the heat side of the triangle, we get heat through compression of air. So we have a sealed cylinder. The piston comes up, compresses all that air, which creates the heat. And we need to compress that air quickly, which means we have to have a good battery cables, battery cable connections, and a good starter motor. We need this engine spinning quickly. It's got to be going rah, 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 rah. It can't be going rah, 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 rah. You're never going to get a diesel engine with a starter with a slow crank. So we need this engine moving quickly in order to create the compression and the amount of heat we need. So we need a good turning force. Some engines may have preheat devices such as glow plugs. And so a lot of people think, oh, we only need to use glow plugs when it's cold out. No, you're supposed to be using your glow plugs for the initial start of that engine, even if it's 90, 95 degrees outside. The engineers consider this engine cold when it hasn't been run, not the outside temperature. Now you may be able to crank it enough to get that engine started when it's 90 degrees out. But you should be using those glow plugs when you do the initial startup on any day. And if it's been sitting for 5-6 hours because you've been sailing all day, then that next time you start it, use the glow plugs for whatever amount of time you're supposed to use them. It varies depending on the age of your engine. So modern engines, the glow plugs pretty much are about 10 or 11 seconds on the button. Older engines, it could be 20 to 30 seconds on the glow plugs. Nope. Yeah, so this engine doesn't have glow plugs and doesn't have the air heater either. So you're showing signs of some age. So if you have trouble starting your engines in the spring and fall because the temperatures, outside temperature, are dropping, that means your compression in the cylinders are probably a little bit on the borderline being low. I mean, you can try, putting a space heater and heating the engine up, ahead of time. Yeah. I mean, you can try using a hair dryer on the intake and pull that hot air into the intake while you're cranking it. It usually takes 2 people. I don't recommend starting fluid. Starting fluid is a no-no on a diesel engine. I call starting fluid diesel engine crack. Crack cocaine for diesel engines. So the ignition point of diesel fuel, according to this firefighting website I went to, is 492 degrees Fahrenheit. So we're actually creating almost 1,000 degrees in the cylinder when we're compressing all that air. The ignition point of starting fluid, which is ether, is about 192 degrees Fahrenheit. So if we're creating 1,000 degrees in this cylinder with the piston coming up, how far do you think that piston travels before it creates 200 degrees? Halfway, 3/4 of the way. So what happened is when you hit this engine with starting fluid, that starting fluid ignites before the piston's actually high enough in the cylinder to actually come back down. So you only have opposing forces, and a lot of times it's the piston that loses. So most of our pistons are made out of aluminum. And so when you have opposing forces, then that piston compresses down a little bit. There's rings called piston rings on the outside of that piston, which are they're split rings, so they spring out. And so when you put this piston into the cylinder, you have to use a special tool to compress those rings down so it slips into the cylinder, and then they expand out and make a seal to the cylinder wall. And so what happens if you use ether, that piston compresses down, and then it pinches those rings in the grooves, and they can no longer expand out to the cylinder wall to make a good seal. And so you got the engine started, but the next time you go to start the engine, you now have less compression than you did before, because those rings are no longer fully expanding out to the cylinder walls. So the next time you go to start the engine, you're cranking, your engine's going, nope, give me my crack cocaine hit. So it's telling you something. If you need to try and use starting fluid, your engine's telling you there's something wrong, and you got to figure out what is wrong. Don't mask it by using the starting fluid. And so there are some things you might be able to get away with, like using WD-40. So you can spray WD-40 in your air intake, which has a lower ignition point than diesel fuel, but higher than ether. And it also, once it gets into the cylinder, it acts as a lubricant, and it will actually temporarily seal the piston to the cylinder wall and actually give you a little bit more compression, which will give you more heat and be able to start. I have started some really old engines with WD-40 in the past, so it does work. All right, so we talked about glow plugs, compression, and we've also talked about the battery cables and connections and starter.
Fuel filters? You gonna talk about fuel filters?
If we get that far today.
Because sometimes they're a problem.
Yeah, well, that's would be fuel delivery. All right, diesel fuel. Diesel fuel is more like vegetable oil than it is to gasoline, which is sometimes a little strange for people to understand that. Because a lot of people think, oh, they both get pulled out of the ground, they both get refined, they both get sold side by side at the gas stations or fuel stations, and the stock market affects both of them equally, the prices. However, diesel fuel is fairly safe to be in a boat, where gasoline is not exactly that safe. So if I took a bucket of diesel fuel and I put it in front of the room and I struck a match, I could throw that match into that bucket of diesel fuel and that match will actually go out, get extinguished. Now if I took a bucket of gasoline and put that and struck a match, the match wouldn't even make it to the bucket, because the vapors coming off of that gasoline are so volatile that the vapors will actually ignite and then travel to the liquid, and then we get the good Hollywood ball of flame in here. So diesel fuel is really safe for boats, but when you do get a diesel fire happening on your boat, usually your boat can't be saved because the fire is so hot that it's just going to burn down to the waterline. And actually your engines can run off of vegetable oil once. The problem is it's a little bit too thick. It doesn't flow through the system properly. So you can run it, but then you have to actually be heating it up in order for it to flow. All right, so there's lots of energy in diesel fuel. So this is a study done by the U.S. Department of Energy. So here in number 1 was the diesel fuel, then you have biodiesel, here you have gasoline, but that's not what we buy here in Maryland, because we have ethanol in our gasoline. So E85, that's ethanol, so it's at $6.90. So if you compare our ethanol gas to diesel fuel, look at how much more gasoline we have to burn to do the same amount of work as diesel fuel. So diesel is safe and more efficient to use than gasoline. And then down here you have your propanes, your your ethanols and ethanols, and down here we have our batteries. This is why the electric boat doesn't work. It's not a lot of energy there, and this doesn't even contribute to weight. So you start adding up the weight of the lead and compare it to diesel. It's just not renewable. And they're getting close to being able to have electric boats, but the renewing the charge in the batteries just isn't there yet. It doesn't matter how many solar panels, wind generators, and all that you throw on the boat, it just will not regenerate as quickly as you're using it. Unless you have a fast boat and you can pull one of those water vanes behind you, then that will create enough electricity. But those people are pretty much the catamarans that can go that quick. All right, so we're going to talk about Boyle's law, auto ignition compression ratios. Here's Boyle. You don't really need to remember this, but he's the guy that came up with the idea that there's a relationship between pressures, volumes, and temperature. And this is what Rudolf Diesel used his idea on this to actually design the compression ignition engine. And I think this formula is actually outdated now. Anyone a physicist in here? But there's another variable in there. So there's always something there. I need to write it down and change this. But yeah, so he's the guy that came up with the idea that it's a relationship between pressures, volume, and temperatures. And so basically he came up with the idea that if you take a volume of air and you compress it rapidly, that the temperature goes up. According to the author, Nigel Calder, of the book we use in our classroom, he says the ignition point of diesel fuel is 750 degrees Fahrenheit. Like I said, I found it on the internet at 492, so I'm not sure exactly where he came up with this number, because no numbers are actually ever rounded off like that. It's like 492, it's never perfectly good. So we're not sure where he came up with that, but here's the slide. Compression ratios. So you'll hear different engines have different compression ratios. So here we have a 20 to 1 compression ratio. So diesel engines have higher compression ratios because we have to create that heat we need. So diesel engines can range from like 17.5 to 1 up to about 24 to 1. Now the gasoline engines that you drove in here are probably like 8 to 1 or 9 to 1. Now there are some engine manufacturers, I think Honda a few years back actually started playing around with gas engines with higher compression ratios to ignite the fuel, use gasoline with compression ratios, which you can do when you have multiple or multi-port fuel injection, where the fuel is being sprayed directly into the cylinder versus into the intake manifold. All right, so this is graphically accurate. So if we compress this volume of air to 1/20th the original size, that's what it would look like. And so we're going to go from roughly 7 degrees Fahrenheit up to about 1,000 degrees in a split second. And so if we know the ignition point of diesel fuel is 500 degrees, then if we spray diesel fuel into a 1,000 degree environment, it should auto-ignite. Here's some vocabulary. Here, this is a piston in the cylinder. So the lowest point of travel the piston makes in the cylinder is called bottom dead center, BDC. The highest point of travel the piston makes in the cylinder is called TDC, top dead center. And the difference between the two is our compression ratio. What else? The width of the cylinder is what we call the bore, and the length of travel is what we call the stroke. So if you know the bore, the stroke, and the compression ratio, you can actually figure out what your compression in the cylinder should be. Because not all manuals are going to actually tell you what your compression is supposed to be. For whatever reason, they like to keep it a secret. So you do a compression test, but if you don't know what the numbers should be, then what's the point of... I mean, you can compare the numbers with one another, make sure they're within 10%, but you should know what the brand new specs are and what the minimum requirement is before do I need to go and rebuild this engine. All right, so here we have what we call direct injection. So you can see the tip of the injector directly on top of the piston, and it's spraying the fuel mist in. And so when we spray that fuel mist in, and we have the heat there, that fuel is going to automatically ignite. It's going to auto-ignite. And then we're going to get the expansion of gases. And that expansion of gases is going to force this piston down. Like that. So we get the expanding gases, forces the piston down. At that moment in time, we've taken fuel, air, and heat and converted it to mechanical force. Now the rest of the idea is to get that mechanical force to the propeller so we can turn that propeller to move this boat through water. And movement of the piston down like this is what we call the power stroke here in the U.S. If you're from Europe, they call it the expansion stroke. Here in the U.S., everything's about muscle power. All right, so direct injection and indirect injection. So you can see here the injector is spraying directly on top of the piston, and on this one, there's a pre-combustion chamber that the fuel is spraying in. So when we're compressing the air, that air is going through this tiny little hole, and it's actually superheating that air that's going into this tiny little pre-combustion chamber. So when we spray the fuel in, the temperature is actually hotter in that little cup than it is on top of the piston. So the fire starts in that pre-combustion chamber, and then it blows out and fills the space and then forces the piston down. And so a lot of times on engines with pre-combustion chambers, you kind of hear an injector knock. You all probably don't notice it, but it's a little extra clack that happens when the cylinder fires. All right, so we talked about surface area already, fuel-air ratios, and we sort of talked about mechanical versus electronic. So a mechanical fuel-injected engine, the engineers designed this engine with a set of variables in mind, meaning the air temperature going into the engine is going to be at this setting. The coolant temperature of the engine is going to be at this setting. The atmospheric pressure is going to be at this. The outside temperature is going to be at this. And so they've taken all these variables that they decided to use, and they designed this engine to run within all those variables. Now, when those variables change, such as it's 30 degrees outside, And this was designed to be run at 90-degree outside temperature. Then our variables are all out of whack. So this engine is not going to burn nice and cleanly, and it may not run smoothly. And so this may produce like a whitish gray smoke because the cylinders are extremely cold because of the outside temperature. The outside air going to the engine is super cold, and so it's basically not exactly running lean, but there's extra oxygen because the molecules are closer together for the amount of fuel we're spraying in. So it's going to put out more of a whitish gray smoke coming out the exhaust. But what happens with an electronic engine is the computer is connected to sensors all over the engine. So the computer knows that everything's out of whack, and the computer will try and change different things on the engine so it doesn't produce smoke. So it can change when it sprays the fuel into the cylinder, how much fuel it sprays into the cylinder, and if it can't make enough changes to not produce smoke, then what it'll do is it'll put you into a fault mode, or also known as a limp mode. And it will reduce the amount of RPMs you can get out of the engine, so you can limp back to port to get a repair made if there's something seriously wrong.
Do the shear requirements vary according to the horsepower of the engine? Shear requirements for the
Shear emissions? No, they're all the same. I'm pretty sure. Maybe it's tier 1, tier 2, tier 3. I think we're in tier 3 now.
so all three ranges tend to be electronic.
Yeah, so it starts off at the higher horsepower and then it trickles down to those. Alright, so once you start throwing turbochargers and aftercoolers and stuff, it becomes harder and harder to actually have the engine running clean because you're putting so much fuel into it. And so pretty much anything under 100 horsepower can be a mechanical engine. With Yamar's line, they jumped the gun with their engine line. So everything below the 30 horsepower is mechanical. Everything above the 30 horsepower is electronic. So if you were to buy a brand new boat or
After what year?
I think 2014, 2015, they started using the computers on the Yamars. All right, so we talked about spray patterns of our coming out of the injectors. So you got your good and your bad. So we can see on the good one, we got a fairly even cone coming out. Now, obviously it looks like it's a little blank right here and here, but I think that's just the way the flash hit the spray, because it can't just disappear. But on this one, you can see the blank coming from the tip all the way down, from the tip all the way down, from the tip all the way down. So this has a very bad spray pattern to where this is a nice even fog of spray coming out. All right, so this piston's been cut away. So you can see this piston has what we call a swirl cup on the top of it. So this is direct injection. So direct injection has multiple sprays coming out of the injector on angles, like we see it. So it may have between 3 to 7 sprays coming out. Usually it's about 5, a little star pattern coming out. And this swirl cup, so you can see this peak right here. So when the piston's coming up, it causes the air to rotate like this in that cup. And you can see the fuel is spraying the opposite direction of the air movement. So you get the oxygen molecules and the fuel molecules going opposite of each other. You get a better mixture, a cleaner burn. Here we can see a glow plug going down and it's bright orange, letting us know that it's on. But the only time the glow plug is actually on is before you actually start the engine. And so once the engine's running, they don't turn on anymore. And it just goes bang, let us know we're ready to take a break. Oh, no, what'd I do? Yep. All right, black smoke is because we're running rich, so we've got more fuel than the amount of oxygen. We have defective spray patterns, high ambient air temperatures, insufficient airflow in or out of the engine. And like I said, electronic fuel injection will do away with this because the computer won't allow it. It will try not to allow it. 4-stroke cycle. All right, the movement of the piston down the cylinder is a stroke. The movement of the piston up the cylinder is a stroke. So to go through a 4-stroke cycle, it's going to go down, up, down, up. So the first stroke is the intake stroke. On the top of the engine, we have our cylinder head. In the cylinder head, we have valves. So we'll have an intake valve and an exhaust valve, at least one of each on each cylinder. And so the intake valve will be open and the piston will move down for the intake stroke. So it's going to create negative pressure and it's going to draw air into the cylinder. That's our intake stroke. Okay. Once it gets to the bottom, that intake valve closes. Now we have a sealed cylinder. The next stroke is the compression stroke. Piston comes up, compresses the air, creates the heat. Just before the piston gets all the way to the top, we start injecting atomized fuel into that hot environment. That fuel ignites, then we get the expansion of gases, we get the power stroke. Forces the piston down, now we have a cylinder full of smoke. The exhaust valve pushes open, piston comes up, pushes all the exhaust smoke into the exhaust manifold and out the engine. So intake, compression, power, exhaust. Now every diesel course ever taught is going to tell you 4 words to remember this by, and that is suck, squeeze, bang, and blow. And this is what it looks like. So this is one cylinder going through all 4 strokes. So we have an intake valve and an exhaust valve. So the exhaust valve you can see is closed, intake valve is open, so you can see there's a passageway for the air to get past it. We've got little arrows here. So down, it draws air to the cylinder. Just like your diaphragm does. Your diaphragm pulls down, pulls air into your lungs. That valve closes, now we got a sealed cylinder, piston comes up, creates the heat. Just before we get to the top, we start spraying fuel in. That fuel ignites, we get the expansion of gases. That forces the piston down, that's the power stroke. Now we got a cylinder full of smoke, exhaust valve opens, piston comes back up, pushes all the smoke out of the cylinder. So now you're starting to realize this machine isn't quite as complicated as you think it is. Now the fuel system kind of is complicated, the injection pump and stuff like that. But the actual piece, moving pieces and stuff, it's really just parts. 2-stroke, we're skipping that. All right, so where are we at? We're moving quickly today. All right, so I guess I can jump into anatomy a little bit, or y'all want to just start asking questions? What pulls us?
Steve, give him the microphone.
Okay, he asked what makes the piston come back up. Well, there's a crankshaft that it's attached to. So we've got a connecting rod which is attached to a crankshaft. On the back side of that crankshaft is a flywheel, so it's this big heavy metal disc. So when you get a heavy metal disc in motion, it wants to stay in motion, so you get this inertia. And that's how you could have a 1-cylinder 4-stroke engine. Because you get the 1 power stroke, but this big heavy wheel wants to keep moving when you get it spinning. And so it'll pull that one piston through the other 3 strokes. And so we have a big heavy flywheel which helps pull that crankshaft around.
Are all the cylinders in the same stroke cycle at the same time, or are they operating in sequence?
There's a sequence. And so on a 2-cylinder, they're 180 apart from each other. On a 3-cylinder, they're 120 degrees apart. I guess on a 4-cylinder, they're 90 degrees. And just keep dividing by cylinders. 360 by amount of cylinders.
But in REM, typically, when one is on the exhaust stroke, another one is on the power stroke, so you've always got power driving the crankshaft to turn the other cylinders
On a 4-cylinder, yes.
on 4-cylinder. Or close to it, but not to.
Yeah. Even on a 1-cylinder. It's easy to remember the firing order in 1-cylinder.
What?
That's why they're called 1-bangers, because that's what they sound like. It goes bang, 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 All right, so here's our piston, there's the
Hey, Scott.
cutaway. So I told you we
Scott.
have rings.
Hang tight.
Oh, okay.
If you've got a electronically operated engine and you're out of country, is there certain things that you would bring with you as spares that you might not normally carry in country? In other words, is there such a thing as a spare computer, I guess, is what I'm asking.
The problem with a spare computer is you usually have to install the software into it.
So there's really nothing you can do, is what you're saying.
I mean, you can talk to your engine manufacturer to see if there's a preset software already built into it. But from what I understand is when you install a new computer, you actually have to connect the laptop and upgrade the
It has to be
latest software.
programmed effectively.
You have to reprogram it, yeah,
That makes sense.
and set it up.
So then basically, if you've got a bigger boat, you have very limited options. Because I mean, if you're in the middle of nowheres and, you don't have the fancy gadget to plug in, then I guess you just have to, I don't know, what are you supposed to do?
Yeah. That's the problem with the modern technology. There's no longer MacGyvering, to get home. You're kind of stuck. Huh? Yeah, but there's some things that even the limp mode you won't even get to that point. You've only got to get the engine started. Some possibilities. Any other questions? All right, so we talked about the rings. So the top rings are going to be compression rings, and the bottom ring is an oil scraping ring. Because we got engine oil down here making lubrication, and we don't want to get that oil to the top side of the piston. Because if we get oil to the top side of the piston, what's going to happen? We're going to burn it, but it's not going to be black smoke. It's going to be blue smoke. So when you see blue smoke, that's burning oil.
And you probably can't turn the engine off.
What's that?
And you probably can't turn the engine off normally. You have to block the air.
Well, we're not talking about a runaway, it's just burning oil. Yeah, so the bottom ring is an oil scraping ring. This is what we call a wrist pin or piston pin. That's where the connecting rod connects to the piston. And that's how we can have a reciprocating motion of the piston going straight up and down and the crankshaft going in a circle through the usage of that wrist pin, which allows that connecting rod to sway back and forth. So the piston's going straight up and down, but the crankshaft's going in a circle. So the connecting rod is doing this. Now, where the connecting rod connects to the crankshaft, there's a thin piece of metal in here called a bearing. In this case, it's called a rod bearing. And it's made out of softer metal. So the connecting rod's made out of hardened steel. The crankshaft's made out of hardened steel. And generally, you don't want two pieces of hardened steel riding on each other. And so we put sacrificial metal in between the two, which we call a bearing. And usually they're copper with some sort of alloy coating on the outside of them. To protect these bearings, we change our oil on a regular basis, and we use a higher quality oil. So when we do oil changes, we gotta make sure we buy diesel rated engine oil. You can't just go to the store and just, 1540. You gotta look at the back of the bottle, make sure it's rated for diesel engines.
Can I ask you a question? It seems like diesel engines use a lot more oil than a conventional gas engine. Is that true? I mean, like 10 quarts instead of 5 quarts? I know trucks use very small oil.
You mean just capacity wise?
Yes, I'm asking.
I guess.
Okay. No,
I mean, this guy depends on the horsepower range, but it could hold probably between 6 and 9.
it seems like a lot bigger.
Yeah.
Frequency of oil changes in diesel or gas.
Oh yeah. Well, you got to think about your boat, comparing it to a car. So a boat moving through the water would be like driving your car uphill its entire life. There is no coasting on a boat unless you're in really heavy seas where you're going down a big wave. But typically a boat is just like going uphill, just constantly working. There is no release of taking your pulled off and coasting and then putting your accelerator back down. And so the diesel engine is just constantly chugging along and producing torque. And so it breaks down the oil quicker. And that's the only thing that's protecting our engine, our expensive engine, from deteriorating. So changing our oil every 100 to 200 hours or once a season is a fairly inexpensive service compared to buying a new engine. You know, so this engine, I would assume, is probably, well, you can't get this engine anymore because it's now an electronic engine, but I would assume it's probably about 18 grand to 21 grand to replace this engine. And so an oil change for it is probably going to be $100 between oil and the filter.
And you typically got more displacement on a diesel per given horsepower than you have on a gasoline engine.
It could be.
Because it turns a lot slower. So therefore.
Yeah, horsepower is just a funny word that they typically aren't using it too much in the marine world anymore. Because horsepower is just a combination of RPMs, revolutions per minute, and torque. And so this is a 75 horsepower engine. This engine's developing 75 horsepower because it's turning the engine to 3,800 RPMs. But I can have an engine the same size produce, 150 horsepower, and it only turning up 2,800 RPMs because it's developing more torque. So it's got a harder push of the flywheel at a slow speed versus spinning it up real fast like a Corvette. And so, 100 horsepower diesel compared to 100 horsepower gas engine is just apples and oranges. You can't compare it. Even in the diesel world, you really can't compare 125 horsepower to 125 horsepower.
So I've taken oil changes on several small sailboat engines, and it seems like half of them the oil is completely black, and the other half of them it looks very clean. And I wonder if there's any significance between those two observations.
Well, oil changes vary depending on the engine and your technique. So some engines have a well-designed system to pump the oil out from the very back of the oil pan, so you can get all the oil out, or 99% of the oil out. Where some engines, there's not a good way of pumping the oil out. So when we look at, we're now on day 2 conversations of my diesel crews.
Well, most of these are pumping them out of the dipstick.
What brand of engine are we talking about?
Either, like the Yanmar or the.
Okay, there's never been a Yamaha that I can't get a really good oil change on.
Yeah.
So that would be a technique problem. But if you have like a universal engine,
Yeah, there's a couple of universals
which
too.
is a Kubota tractor engine, where Universal just took the Kubota tractor engine and they marinized it. They didn't think about oil changes or anything on these units. And so a lot of times they would put an oil change kit onto the bottom of the oil pan, but it's the oil pan is still the original oil pan that it would be when that engine was used for like a Bobcat or a tractor or something. And when those units get serviced, they always sit on level ground. So where that drain plug on that oil pan is didn't matter because it's always the lowest point. But our engines in a boat usually are mounted on an incline. And so if that drain plug is near the front of the oil pan, then when you connect your oil changer to where that kit is connected, you're leaving a third to half of the dirty oil is left over in that oil pan because you can't get it all out because it's not coming from the back of the pan. And so you put fresh oil in it, you start it up, take a look, looks like you never changed the oil.
You said I'll change the oil every 100 hours or once a season. If I change my oil, but I only run the damn boat like 6-7 hours that season, do I still need to change it at the end of the season, or is it good for the next season?
That's up to you. I mean, Generally, if you get closer to 30 to 50 hours, we would say definitely. But if you only got 7 hours on it, it probably didn't need to be done. But if you still only have less than 20 hours combined in 2 years, change it.
What about the 3-year fall?
Well, we always recommend doing it in the fall. That way you're storing the engine with nice clean oil, because you can get different types of acids and stuff get into the oil, and those acids can eat away into your bearings. And so it's best to do a service in the fall. That way it's being stored with fresh fluids in it, and it won't slowly deteriorate, and it'll make your engine last longer.
Back to your original slide on the fuel injectors, by way of example, on a Yacht cylinder, is that the DIY part of it, or is it removing the sensor to your shop like yours? Do we remove them and send them to you, or is that DIY?
Yeah, we rebuild. We rebuild injectors ourselves. There are some injectors you can't rebuild. So a lot of the Caterpillar 3208 injectors we can't do. Some of the 6-cylinder Yamahs we can't do because they have injectors in which are called 2-stage injectors, and they got to be put on a special machine. But I would say probably 90% of what we work on, we can definitely rebuild them ourselves. And then electronic injectors we can't do because they have the little electric solenoids on them.
Is that something an engineer or boat owner could do, or would you just?
Well, you need a special tool to actually rebuild them, to test them. I mean, yeah, you can pull them apart, put new tips in them, but you won't know what the pressure is required to make that spring compress. And so you need a tool in order to check that. But yeah, you can pull your own injectors out and drop them off or send them to an injection shop. I mean, that's when you start talking about the cost, getting the injectors out and putting them back in, some engines they pop right on out, and some engines it's not fun. I mean, I've had to pull cylinder heads off in order to get injectors out before because they get rusted in place.
Could you explain why warm engine temperatures make it burn rich and leave black smoke, and cold engine temperatures could leave the white smoke? And what can you do about that?
Okay, so let's go back to science class in high school or middle school. So we know hot air rises, cold air sinks. Hot air rises because hot air is lighter, because the molecules, when they're heated up, they get further apart. Cold air sinks because all the molecules are closer together and it's heavier, and so they sink down. So when you have a hot engine room, the molecules are further apart, so those further apart oxygen molecules are getting pulled into the engine, so actually not as many oxygen molecules make it into the cylinder. So that's why it runs rich and produces black smoke with a hot compartment. Now, having the whitish gray smoke when the air is really super cold, it's not exactly a problem, it just doesn't look that great. What can you do about it? You can put a heater in your compartment, so it's starting off at a warmer temperature, and then once your engine actually is up to operating temperature, then the compartment itself should be hot enough to where it shouldn't affect the smoke coming out the back of the boat.
Back to the blower, thank you for letting me know that, because I just thought after you refueled, you threw your damn blower on. What is the detriment to the engine if I'm not, since I haven't been running my blower while I've been running my Cat 328, which you somehow, unfortunately for me, don't refill injectors for?
Okay, so so not running your blowers if it's required. Not all compartments are sealed so tight that the engine compartment's really hot. Now you can see how hot your compartment gets by going to your hardware store and buying one of those indoor-outdoor displays for weather and stuff. And so it's got a wireless display, and then it's got a remote sensor that you can install at the top of your engine compartment and close all your compartment up and then go for a boat ride, run it for half an hour after your cruise RPM and actually see what the temperature of the compartment is.
I know it gets pretty warm. I've climbed in there after we shut it off, and I was sweating before you know it. It's pretty warm down there. I mean,
Yeah.
they're not wasting anything. They're wide open, but still, I mean, that engine compartment gets really hot. I just didn't know if it would damage the engine at all. Not running the blower
it can cause your, you know, mixing elbows to clog up quicker, your injector tips to get more carbon on it, you know, because you're not going to get a complete burn because you don't have enough oxygen because of the amount of heat.
If you did do that Home Depot fix, you know, about the, temperature gauge, what would be a normal operating?
Well, we want to see temperatures under 120 degrees Fahrenheit
When it's closed?
when it's completely sealed up. You know, so if it's hotter than that without the blower running, run the blower and see if it comes within the range or below the range.
What is the range?
Below 120.
Oh, just, okay. There's no lower, right?
No.
So I know on some engines you can do like an oil test, and I guess the idea is that's supposed to indicate the amount of wear on the engine, the age of the engine.
Mm-hmm.
So is that something you agree with, and how often do you recommend that we should be doing oil tests?
Okay, so if you're going to send oil samples out, you have to do it on the regular. Like every time you pull that oil out, send it out. And so doing one test, so you hear a lot of people go and I'm going to go buy this boat, or I'm looking to buy this boat. I'm going to send an oil sample out of this brand new, or this engine, old, the used boat. Most people who put boats on the market do a service to it before they put it on the market. So you're basically sending out fairly new oil. So it's not going to tell you a whole lot usually. But you want a baseline. So doing one test doesn't really tell you a whole lot unless there's something like majorly wrong with the engine. But you want a baseline, just like when you take barometric pressure readings. When it changes, then you know low pressure system or high pressure system is moving into the area. So we want a baseline of what all these chemicals are, and then when we see a spike in something, then we know, okay, we're really high in fuel, or we're really high in antifreeze. Then we can think about, you know, what's causing it. But with this information, what are you prepared to do when you get that information of a spike? Are you willing to pull the engine apart and rebuild it and put it back together? Or, you know, sometimes too much information, you know, ignorance is bliss, as they say.
Tell your doctor that.
Can you talk, I guess similar to can you talk a little bit more about older engines losing compression, and how should we go about, you know, evaluating that's an issue?
Okay, so typically getting low compression, it's either going to show up as hard starts, like we were talking about here with in the spring and fall. It's harder to start. During the summer, it starts right up. That's usually an indication that the compression is low in all the cylinders. Now, if you just have like a misfire, or the engine's not running smoothly, that just might be one cylinder, something happened in that one cylinder, and the others are okay. So you can do a compression test to see what the compression in the cylinders are, and then there's something called a wet test, so you put liquid in the cylinder and do another compression test, and if the compression comes up, typically that means it's a bottom end problem, which is more expensive, meaning the cylinder walls and the rings something's wrong with them. But if the pressure doesn't come up when you do the wet test, then usually that's a top end problem. Valves, valve seats, possibly head gasket. But just because it doesn't change when you do a wet test doesn't mean it's not a bottom end problem. I did have one engine fool me badly. Did a compression test, did a wet test, it didn't come up, so pulled the cylinder head off, had the head rebuilt, put it all back together, started back up, and that cylinder is still misfired. So pulled the engine out, pulled the pistons out, and the front cylinder, the connecting rod was bent, which was odd because normally when you see bent connecting rods, usually it's the back cylinder because seawater, if you ever get seawater into your exhaust, that seawater usually tends to go into that back cylinder because the engine's on an incline, because that water's going to run this way first. And then liquid's not compressible. So if you get a slug of water on top of the piston while it's moving, something gives. But this was on the front cylinder, which was a little confusing. And so I was grilling the customer. It's like, you know, I don't know. And so after I rebuilt the engine, ran it in the shop, everything was great. Put the engine in the boat, did the alignment. Now I'm running the engine up to temperature, making sure everything's good, no leaks. And And while I'm waiting for it to heat up, I'm kind of just looking around the boat, and on the chart table I noticed a can of starting fluid. And I had asked them, have you ever used starting fluid on this engine? Oh, not me. But yeah, so that was one that tricked me, because the connecting rod was bent, so the piston wasn't coming up as far, so you weren't creating as much heat as it was supposed to. So it's not absolute when you do a compression test.
You talked about oil changes, you were talking about like on the end on being able to, get,
Mm-hmm.
you never get 100% of the oil out, but 95 or
Right.
whatever it is. Some of the MRs, the 3Js and the 4Js, you got the dipstick where a lot of people are stuck out of it, but then there's also a plug that's not a drain plug, it's kind of on the side of the crankcase.
Yeah, that plug's there, so
Yeah.
if you need another dipstick
Yeah.
that's easier to access on the other side, that's a hole for the dipstick.
What's your preference?
My preference is this tube right here that this dipstick's going into is a pump out tube. You don't send the tube down the oil tube. You go over the top of it, outside of it. Now there is a tiny little hole drilled at the top of it. You just have to make sure you cover that hole when you put your vacuum pump on it. And because this dipstick goes to the very back corner of the oil pan. So you're going to get an extremely good oil change by using that dipstick. There's no reason not to use that tube.
Silly question, but I got the EMR service kit, and they sent me SAE 30, and I used that, and then this year I went to go do the oil change, but couldn't find that, so I used 15W40, because that's what Google said, for my 2GM20F. What kind of oil should I use for a 2GM20F?
Okay, so I use Shell Rotella. Okay, and I mean, you can use either or. I mean, the manuals, I mean, when you're looking at your operator's manual, it gives you temperature ranges depending on what they, and they overlap. So you can use straight 30 weight, or you can use 1540. But I mean, if you're running your boat up in Nova Scotia or something where it's colder, you may want to go with the 1540. But if you're running down in the Caribbean, you may want to use the straight 30 weight. I mean, here in the Chesapeake, you can use either. 1540 is great. Straight 30 is great. Straight 30 is probably a little easier because your transmission is probably taking straight 30. So you can just buy one oil and use it for both units.
My engine has the drain hose at the bottom where I can hook my pump up to it. So with that creating enough vacuum within the oil pan, so if there's any oil in the corners, it'll draw it out, or will it just still sit there?
What engine do you have?
That's Cat 3208.
That should be going to the back corner of the pan, or the very back of the pan. So
I'm just saying though, but does it create enough suction from that pump that if there is any oil that drain plug is missing, that it'll draw it out?
I mean, it's going to be gravity to that spot.
Okay.
So it's not going to create so much vacuum that it's going to pull it from little nooks and crannies.
Okay.
The Volvo D6, the same question. It's got the little tube on the side. Same thing, you don't have to stick a pipe down into the tube.
The D6, I'm trying to remember. It's been a while since I've done the D6. I don't recall it being anything fancy. I don't recall having to do anything special. Just hook an oil changer up to it, from what I recall.
On the subject, you recommend changing oil hot or cold?
Definitely hot.
Hot.
The hotter the better. So getting the oil hot does a few things for you. One is it suspends the contaminants up in the oil. So when you go to pull it out, you pull more of the contaminants out. Secondly, it makes the oil less viscous, so it's thinner and it pumps out quicker. And third, hot oil, once you shut the engine off, more of it will run back down to the oil pan. So if it's not quite hot, then it may be a little thick and take longer to make its way back down to the bottom of the oil pan. So you won't get as good of an oil change. So the hotter you can make it, the better off you'll get results.
after running the engine, just to follow what you just said, after running the engine, so the engine's nice and hot, the oil's nice and hot. When you turn it off, how long should you wait before you pull the engine, the oil out?
Not typically immediately. I mean, I don't really wait. I mean, because it's most engines is going to take, even with my 12-volt oil change pump. Usually, it still takes like depends on the capacity, obviously, but a little 4-cylinder like this, it's probably going to take me maybe 2 minutes to pump it out. You know, so by the time you get set up and everything, it's probably been draining down a few minutes
And all
already.
the engine oil is drained into the pan.
Yes.
Sorry to be a pain in the ass, I just got a generalized question. Other than your normal hardware parts, your connectors, wire connectors, are there any spare parts you recommend other than impellers and maybe the sacrificial end to keep on board? So if something goes wrong, like water pump, I mean, what spare parts?
Okay,
I mean, I know we only have so much storage, so we can't
Right.
keep everything,
All
but.
right, so for the weekend warriors, which is probably most of us, the fast moving parts. So oil filters, coolant, belts, air filters, impellers, fuel filters, oil filters, oil filters. And the oil filters you want to be using on your engines should be OEM, original equipment manufactured filters. Don't be putting Napa filters on your engines unless your engine's 50 years old and you can no longer buy it. OEM filters, there's something called a bypass valve built into every oil filter. And so if the filter clogs, this valve pops open and allows oil to continue to lubricate the engine even though the filter is clogged. Now when you buy an aftermarket filter, you don't know what the setting for that bypass valve setup, because that oil filter from Napa might fit 200 to 300 different engines. Which one was it made to screw onto originally? So the only way to know that you've got the right setting is to buy the original equipment filter. Now, a lot of people think that buying marine parts, you're getting that's overpriced. My supplier for these Yanmar filters are almost like $7 or $8 cheaper than buying a Napa Gold filter. So it's in your brains thinking that aftermarket's cheaper. And a lot of times aftermarket, the material it's made out of is thinner. So when you actually go to remove it, they crumble down and then you're sitting there with a screwdriver trying to chisel it around. And so it's actually cheaper to buy the OEM filters typically, especially if you go to Amazon and buy them off of Amazon, or the internet is usually someone's always trying to save you a couple dollars so they can get the volume of turnover and sales. So.
Can you talk about when you change oil, pulling it back in? I'm talking, I have a 3GM.
Mm-hmm.
And it doesn't, I mean, the dipstick, it's a hole.
Correct.
There's no tube there.
Correct.
And so how do you pull, and isn't the crankcase vented anyway?
Well, there is a crankcase vent, but on the GMs, there is no pump out. So my oil changer, I have a plastic tube that I send down through the dipstick hole. And the plastic tube, I keep it coiled up in a bucket. So when I uncoil it, it keeps the memory of a curve in it. So I can take that curve, go down through the hole in the block, and I can get that to curve to the back corner of that oil pan. And I still get 99% of the oil out.
So you're pulling it out through a tube then?
Yes.
Going down to the bottom of it?
Yes.
I see.
Yeah, some engines don't have a pump out, so that's the only way to do it.
Right, I thought you were pulling a vacuum
Well,
from the top of the.
on this engine, yes. So the dipstick tube itself is a pump out. Because it's they design it to go right to the back corner of the oil pan.
On the 3JH, the exhaust mixing rollo that you described, if your exhaust hose is off and you're looking up there, is that sufficient enough to do that inspection of the carbon buildup, or do you have to take the entire sample?
It's generally not going to be, I mean, you might get a slight idea by looking up with a borescope or something, just to look at what they're looking at. But where it really gets plug is in the dry side, and it's depending on which design you have, you may or may not be able to see that the buildup is there. So I know that wasn't a great answer, but
Someone mentioned zinc factor soil. Most diesel engines have them,
every diesel engine does not have the sacrificial anodes. Like this engine doesn't have any. Most Yamars don't have anodes until you get to the larger horsepowers. And so typically when the heat exchanger is built into the exhaust manifold, it typically does not have anodes. If it's a separate piece that bolts to a bracket, then that heat exchanger and the oil coolers will have anodes. But when it's built into the unit, Yamar thinks that everything is completely touching each other, so everything's at the same potential for the galvanic corrosion.
Your parts list. In a couple of years, when he graduates, we plan on living on our boat and traveling ICW and jumping to the Bahamas. So does that parts list change at that point?
Yeah, so when you start doing more serious cruising, like long distance cruising, then there's something called an offshore kit, especially if you're going out in the middle of the ocean. So instead of just bringing the impellers with you, you would bring a whole seawater pump and mounting gasket. They have depending on where you're going, you may want to bring a whole starter, a whole alternator, a complete gasket set. So your investment is going to start getting bigger and bigger and bigger. And if you go down into third world countries, that's when you got to think of, okay, it's only a $3 gasket, but the customs charge to get that $3 gasket in, it's going to run you $40-50, and it may get held up in customs for 5-6 weeks.
Sounds like my wife's closet's gonna get smaller and smaller too. Yeah, it'll go with my closet.
What's the yearly maintenance? Okay, the seasonal stuff is going to be changing your oil, changing your fuel filters, checking your belts, checking your air filters, replacing them as necessary. If you have the zinc anodes, or we don't call them zinc anymore because they don't always use zinc. Sometimes they're magnesium, sometimes they're aluminum. So now we call them anodes. So you check and replace your anodes. At winterization time, you test your coolant for freeze protection, and this coolant is on a maintenance schedule to be replaced every 2 to 3 years, which a lot of people don't do that because antifreeze will break down just from sitting and being used, and it won't have the correct properties to exchange the heat. So we want to make sure we have a good mixture of distilled water and coolant in the engine. Depends on the time of year. I mean, if you're trying to do this when there's no water on the dock, you can't flush it. But if you have the capability of flushing it, yeah, if it doesn't, that's good. And I usually go by, when I drain it out, I look at to see what the color is. Does it look dirty? If it looks fine, then maybe it doesn't need to be flushed out. And I'll do a finger swipe. So I'll open up the pressure cap and I'll put my finger in there and I'll rub it around and see if my finger comes out, brown, like things are rusting or anything. If it comes out nice and clean, then more than likely everything else in the engine is probably nice and clean too.
a winterization question.
Mm-hmm.
Because I winterize the same I thought I would go are there any serious risks under overnight movement?
Yeah, so the coolant that's in the engine, almost all of us are going to be using a 50-50 mixture of coolant and distilled water. The only people that would be different would be the people with the Volvos. I think they use a 60-40 mix. For the saltwater side? Yeah, so on the smaller engines, you can start off with the -60 and just run, like this engine would probably take 2 to 3 gallons, -60, and it'd be winterized. Now, for us, I only bought -100 for the engines and -50 for the domestics. So I didn't bother buying -60. So I was running -100 through all my engines. So when you start getting to the larger engines, which have larger capacities, the pipes and heat exchangers and everything, there's more mixing happening. So you got to start off at a stronger mixture because it gets diluted on its way through the whole system.
But I think what he's saying, you only winterize yours down to 20 degrees, right? And then you only winterize this to go to 20 degrees as far as outside temperature. So he's asking, since the temperature's got colder than 20, does he
Well, that's the part my brain doesn't work around because I just buy it and I pour it in. There is no dilution. The engine dilutes it as it's traveling through the raw water
I just buy
cycle.
the West Marine -50 and dump it in, same with my fresh water tank. I don't know, so he's asking, does he need to worry?
Yeah. Got down to single digits. Yeah.
I can ask specifically for mine, but most of it will be. So I have a large sailboat with an 80 horsepower Western diesel. I've read and heard from lots of diesel things and looked at power curves that diesels are the most happy running at 80%. So max RPMs is 3,400, mine's 2,800. My diesel actually seems to me to be much happier, and it's only like half a knot less, instead of running it at 2,800, running it at like 2,400. It seems happier, it uses half as much fuel. Do you have thoughts on that 80%?
Well, I mean, most manufacturers want to see you putting an 80% load on the engine or generator, doesn't matter which one it is. Now, if you're hull speed, if you hit your hull speed before that 80%, then you run it at hull speed. It's up to you to run it a little lighter. You're just not creating as much heat, so you're going to have a little bit more carboning, on the valves and stuff. But every now and again, like once a day, before you actually get to your no wake zone, run it at full throttle for 3 to 5 minutes. That way you generate extra heat and that will burn that carbon off. And it also tells you the condition of the bottom of the boat and your cooling system. Well, we use Shell Nutella, nitrate free is what we use. For most of our engines, but the Cummins will use the Fleet Guard. Volvo we use Volvo coolant. Caterpillar we use Caterpillar coolant.
If you have time to talk about the fuel filter issue.
Which issue? Well, there's usually 2 fuel filters in the system. So you have a primary and you have a secondary.
The rate core is considered secondary
Nope.
or the primary?
So where's the fuel start at? The fuel starts at the tank. Then the first filter, primary, then that travels through to the engine, which is the second filter, secondary. All right, so here's the primary filter. This is the filter that's mounted on the bulkhead somewhere. So this is going to be a water separating filter. Most boats, not all, usually has a Raycor, which is a brand, which is one of the better filters on the market. This is a 500 series that you see here. This is not a marine filter that we're seeing in this picture here. So this is not a marine filter. This is the marine filter. So what's the difference between these two filters? Well, we got white paint, tan paint, blue sticker, red sticker, amber bowl, clear bowl, plastic drain, metal drain with a metal flash bowl. So the real difference is the flash bowl and the metal drain. So if there's a fire in this compartment, this metal bowl and the metal drain protects the plastic bowl for X amount of minutes so it doesn't melt and pour fuel on the fire. Now, price-wise, this one's probably $100 more expensive. And it takes up a little bit more space because this is about 8 inches wide or so. And then when you go to drain any water or sediment out of the bottom of the bowl, you got this hex plug that you pull out to drain the water out. But you don't want to drain the entire, there's no reason to drain all the good fuel that's in there. You just want to drain the water and the sediment out. So you pull the plug out, and you got a pan underneath it, and once it turns to nice clean fuel, you go to put the plug back in, and you're trying to get it up in there before all of it runs out, and then you go boop, it pops out of your hand, so then you put your finger in the hole and get to it. That's typically what happens. So for my customers, I always suggest that when we put the marine version in, we go with, and I'll tell them that we should put a fuel valve in the bottom of it. That way we can open up the plug, open up the valve, let the water out, close the valve, put that in a bucket, and it's not a Chinese fire drill to try and get it all back together. So.
Are they internally the same?
What's that?
Internally, do they use the same components?
Yeah, internally. So these are the filters that go inside of it. So the original filters look like this, red, blue, and brown. They look like this now. So they're all tan with red writing, blue writing, or brown writing. Now you can't read it in the picture, but this says 30 microns, this says 10 microns, and this says 2 microns. The answer to the next question popping up. Should be running 30s, and every so often there's an engine manufacturer that asks for the 10s in the primary. You should never be running 2s in your primary filter.
Can you convert the filters? I have the one on the left. Can I convert that to the one on the right?
Yes. So you can buy a bowl kit, which is not cheap. Somewhere between $150 and $200 for the kit. So a lot of times it's $300 for the whole unit, or $150, $175 for the bowl kit. Now, most people make that change when they get their boat surveyed, and if you have this style, usually that pops up on the survey, and then your insurance company forces you to make that change in order for them to change.
On the subject of fuel, what about the bio preventer additives and the enzyme additives, all that stuff?
All right, so there's only 3 products I would recommend putting in your fuel, and I only recommend putting it in the fuel if you have to. So lubricity products, because diesel fuel has sulfur in it. Sulfur is a pollutant, so they're slowly removing it out of our fuel, which is causing issues in our fuel systems. So if you're running low sulfur or ultra low sulfur, the sulfur in the fuel was helping protect our rubber components in the fuel system, such as if we had a rubber diaphragm. So here we have a mechanical fuel pump. There's a rubber diaphragm here that moves up and down, which pulls fuel and pushes fuel. We're seeing more and more issues with this rubber diaphragm where it's getting soft and getting stretched out, getting holes in them. In our injection pumps, we have O-rings and seals. We're seeing those swell out, and we're seeing more and more fuel leaks at our injection pumps. And so there is a product we can put into the fuel to help slow that down, and those are lubricity products. Now, depending on where you buy your fuel, some of the fuel docs will say they already have it in the fuel, that they've already put lubricity products into the fuel. Are they not? I don't know. But there are different products you can purchase. I don't push any particular product on you all. Y'all can read and do your own research. Biocides. So in diesel fuel, there's things that can grow in your fuel. It's called, they're microbes. West Marine will tell you it's algae. But algae requires sunlight. So last I looked, we don't have sunlight in our fuel tanks. So we have microbes that grow in our fuel. And usually the microbes grow when you have water in the fuel. So they like to grow on the water and fuel line. And so you can put a biocide into the fuel tank, which will kill the microbes and break them down into a powdered form so they can flow through your fuel lines to be captured at your primary fuel filter. And then you change your fuel filter to remove them out of your system. Now, if you have an extremely bad problem with microbes, you may actually have to call a fuel company to come out and polish your fuel. Well, polishing is just a fancy word for high volume filtration. So they will pull the fuel out of your tank, run it through a couple really big fuel filters, and return it back to the tank. And they'll let this cycle for an hour or two, depending on the company. And some companies may come out and take a fuel sample and see what the chemistry of the fuel is, and then they may put a cocktail into the fuel a couple weeks before they come out to allow it to get into the fuel and break down any of the microbes, et cetera, before they actually start polishing.
So it's like dialysis for your fuel tank.
Yes. Pretty much, yes. And then diesel fuel has a chemical in it called cetane, which is a catalyst, helps the fuel burn. Over time, when you store diesel fuel, the cetane rating of that fuel slowly degrades and over time. Now, if you talk to the fuel companies, they say, oh, after 2 months, it starts degrading. It's actually not that quickly. I wouldn't be too concerned with the fuel in your tanks until it's been in there for 1.5 to 2 years without putting any fresh fuel on top of it. So if you're in the market for buying a used boat and it's been on the hard for 3 or 4 years, then you may be concerned with what's going on in that fuel tank as far as the older fuel. So once that cetane rating starts to degrade, that fuel becomes harder and harder to burn. But it will burn, but it may produce blue smoke out the back of the boat because old fuel tries to turn itself back into crude oil if you let it sit long enough. And so that's why it's going to start producing blue smoke. So we can add a cetane improver and add more points of cetane back into the fuel. I have used this product and it does work, this FPPF. And this will add 8 points of cetane back into the fuel. So this one bottle will treat up to 250 gallons.
For those of us that have sailboats and don't necessarily use fuel or tank up very frequently, what are your thoughts on, obviously diesel, not gas, like or something? Is that the same thing as cetane? Like stable, free steam, one of those kind of things to try to keep the water absorption down?
Yeah, I don't know all the products on the market.
All Steve-O is it's a fuel additive that it's supposed to keep the fuel where it is, and it also has a water absorption chemical part to it to keep it from getting water in your fuel.
Yeah, so as you notice, I'm not pushing any cocktails.
Yeah, you know, like gasoline's only good for 6 months or whatever we're hard on. The Steve-O you put in there, it extends it to like 12 months.
Yeah, like I said, I don't think you need any additives unless you have a problem.
I throw anti-gel in my thing.
Put anti-gel in your?
Just a little bit.
You do boating during the winter?
No, I want to make sure. Last year, I had a diesel truck and my actual truck gelled up and I had to throw 911 in there. So for the boat, I just threw a little bit of anti-gel in there and make sure that doesn't gel up.
Yeah, it's only a problem when you're using it when it's cold. Because the waxes and stuff separate out because of the cold temperatures. But by the time you go to use your boat, it's already separated or recombined. So it's not going to be a problem on your boat unless you're doing wintertime boating.
I just want to make sure I heard you you say usually the cetane is okay for like 18 months?
Like if your fuel tank has not had any fresh fuel added to it in 18 months to 2 years, then you may want to put some cetane improver into it. But if you keep putting half a tank every year back on top of your old fuel, you're bringing the cetane level back up every time you put fresh fuel in.
I think you mentioned at the beginning that 90% of the calls you get could be handled by the owner or the user. And I was just wondering what are some of the most common things that you get called for that could be handled?
I mean, most easiest stuff would be fuel filters. So you have to learn how to change your own fuel filters and bleed out your fuel systems. Another thing is cooling system. You have to be able to change your own impellers. That's a must. And when your impeller breaks, you have to know how to search for the broken pieces. But they don't just disappear. You have to locate the broken pieces. And that's the longest part of the job, is finding the broken pieces. And sometimes they get jammed up in the pump and you can pop them out, but sometimes they end up all the way in the oil cooler or something, and they can be kind of difficult to remove.
Fuel tank, you recommend filling it up completely in winter time, or?
Yes. So it's a double-edged sword there. So one thing is we want to keep the tank full. That way the air void at the top of the tank is as small as possible, because that's where moisture gets in your tank through the vent. So the bigger the air void, the more moisture is going to come in and out when the tank breathes during the day. And so that moisture is going to collect at the top of the tank, turn into droplets of water, then rain down into the fuel. So if we keep the tank full, we'll probably keep the moisture out. But we also don't want to keep the fuel around because of the cetane issue. So you want the fuel, so it's like I said, it's a balancing act. It's easier for power boats because they go through a lot of fuel. The sailboats, it can be an issue.
So you look at all the primary filter, what about the secondary?
Okay, the secondary filter, OEM filter. And so you're buying the micron rating that the manufacturer wants it down to be filtered down to. And they don't really tell you. It's going to be somewhere between a 2 and a 7 micron. The frequency? Now, if you go by the maintenance schedule, it's going to tell you like every 200, 250 hours of running time. It may also say once a year, but for my customers, we just do it all. We do all the filters in the fall.
Couple hundred hours going through filters, on most fuel filters, a couple hundred hours.
Well, a couple hundred hours on your secondary. The primary is going to be done with the oil, 100 to 150 hours. Yeah, but I just do them all because it's actually easier to bleed the fuel system when the secondary's been changed too. You get better results.
You may have just answered it, but if I replace either the primary or secondary fuel system, I'm sorry, fuel filter, that means I'm not enough the fuel system, so do I need to conduct a rebleed after?
Yes, anytime you open up your fuel system, you have to make sure all the air is out of it. Because air is compressible. And our fuel systems are based off of the idea that liquid is not compressible. So we talked about this injection pump before, the plungers. That once you get a measured amount of fuel into the plunger, the cam pushes up on the plunger, it squeezes the fuel through a tiny little hole and sends it to the injector. If we get air in this plunger, that air is going to compress, and we're not going to deliver any fuel to the injector because the air is just going to be compressing down. And if we get enough air in this injection pump, then the engine stalls out and won't restart. So then we'll have to bleed out the high pressure system, not just the low pressure system. So yes, we need to service and get the air out anytime we open up the system.
So the lubricity and the biocide, how do you know if you even need those?
Well, lubricity depends on the fuel you're buying and putting into the tank. So if you're buying ultra low sulfur, you're probably going to need a lubricity product. The cetane is if the engine's if the fuel's been sitting for a year to 2 years, then you may want to add a lubricity product. Now the biocides, when you change the filter, when you pull that filter out, if you see any signs of the microbes, then that may be the indication that you need to use a biocide. So I'll come back a few slides. So this is what microbes look like when they're in their actual living state. So it's this like black jelly looking type of stuff. So this is a screen that goes inside of the facet fuel pump, electric fuel pump.
They'll stop the Mercedes in its tracks.
What's that?
Run the Mercedes, it'll stop in its tracks.
This will stop every diesel engine. Well, see, there is a type of boat brand that use universal engines, and every boat they built, they installed this electric pump in the wrong location. So they put this pump before the racor. So this screen is doing the brunt of the filtering. Now, I'm one mechanic, and I know I've done over 80 boats in my career for this company. Not for them, but fixing their mistake. Yeah, so I'll run the fuel line directly to the racor, and then from the racor to the electric pump, and then to the engine.
That is an important point. The racors are meant to be operated in the back,
Right.
upstream of the pump.
Right, they're supposed to be under a vacuum. Yeah.
Yes, can you comment again? Did you say the biocide is an annual maintenance or only when you detect a problem? Excuse me, not annual, but I've been putting it in every time I fill up. That's what I'm.
I mean, you can use it, but I don't like to put too much additives into the fuel because you can change the chemistry of the fuel and actually cause smoking problems. So if you don't actually have an issue, you may not want to add additives. That's why I say I go by what my filters look like. You know, so if I see issues, so if you're putting the biocide in your tanks now, when you change the filters, are you seeing signs of anything, or your filters kind of look clean when you pull them out? Yeah, so you don't have a grotesque amount of microbes in your tank. If you're using biocides and it's not showing up, then your tank's probably fairly clean. So you may want to start scaling back on that, possibly.
This is gonna sound silly, but when I change my racor, I turn my ball valve off as far as my fuel. Do I need to? If I open that canister up, I was always afraid that I'd open that canister and diesel would just start free flowing out of that
Well,
racor canister.
there is a chance that it can siphon. So yeah, if you shut the fuel off.
I just have a habit sometimes.
And sometimes it might siphon from the return too.
Yeah, I just
So
have
when you
a
go to
habit.
pull your secondary filter out, I've had plenty of boats that a steady stream is coming from the return line.
I just have to have it forget to turn it back on, so then we'll start the boat, we'll start driving, get halfway out to Marina, and the damn thing will shut off, and I'm like scrambling to go turn it back on and get fuel back for the road again.
You mentioned buying OEM filters, which I think makes sense. Are there other parts that you would recommend buying OEM? I think an alternator to the Yanmar is almost $1,000.
Yeah. I mean, Yacht doesn't actually make their own alternators, but some of the alternators they did use, some of the parts on them are no longer available, like the regulators and stuff. And so you can either upgrade to like this white one is a Balmar, which is the most common upgrade for people, brand that they use. And even Yamar offers it as a upgrade when you go to buy the engine. It's up to you. Just got to remember our engines are metric, so make sure you're buying metric stuff. So if you go to Napa, they may give you a metric belt or not. It's hard to say. So you can buy aftermarket impellers, but the problem is a lot of them are made in China and they're not the same quality as buying, but you don't have to buy the Yanmar impeller. This is a Johnson pump that is made for Yanmar, but the impeller in it is a Johnson impeller, so you can actually buy a Johnson impeller kit and it will work in there. The starter's a Hitachi. Trying to find a Hitachi starter is going to be difficult. So you can buy an aftermarket, which is a Chinese knockoff, for like 125 to 200 bucks, or you can buy the Hitachi from Yanmar, which might be like $650 to $700. And so what we usually recommend is buy the aftermarket and then send your original Hitachi to a starter shop and get them to rebuild it. That way you have an OEM that's been rebuilt. So if your knockoff only lasts a couple of years, you have a good one to put back on.
I had a BMW V7, and it turns out that they use a Volkswagen starter.
Yeah.
So I had that rebuilt. Oh yeah, the VW.
Yep. Any other questions?
Back to the impeller. I have spares on my boat. Do those impellers, they're rubber, do they have a shelf life when they're sitting in a
I mean,
spare bin?
they do. I can't tell you how long. If they're in a sealed bag, usually they'll last longer if they're just in a box. I haven't really seen one that completely just broke apart after I put it in. And they're probably 5 to 10 years old. So I would say they're probably got a pretty long life to them.
Do you have any rules of wisdom on transmissions?
Shift that idle? Shift that idle? Yeah, so the main thing is only shift them when you're at idle. And the most important thing is that the cable adjustment. So a lot of times the cable won't be adjusted right, so it's not fully going into forward or reverse, whichever one. And then eventually that, whichever one is not adjusted correctly into, that's the one that you end up burning the clutches up or the shift cone.
It can also prevent you from shutting the engine down, if you're linked to that. Ask me how I know.
I don't know why that would keep you from shutting the engine off.
Well, because there's a linkage between, you have to be in neutral, to shut the engine down, like a regular switch.
I've never seen that. It's usually, you need to be in neutral to start your engine, not to shut it off.
You need to be in neutral to shut it off too.
What engine you have?
The Yanmar.
I don't believe it.
So it's funny, once I tighten the connection up a little bit, then I have the total control again. Didn't have any control before.
I've got folding props because I'm a sailboat and I have to shut it down when I'm underway to fold the props in gear going forward, so the props will fold. And then I move it and put it in reverse and do it there to lock the shaft.
Right.
But I don't shut it down in neutral except when I'm gear stuck.
Well,
And it doesn't make any difference for shutting down my engine.
Well, I don't have that. I've just got a regular.
And which Yamaha you have?
Pardon me?
What Yamaha model?
6-cylinder, 300 horse.
It's a hydraulic transmission.
Yeah. Yeah, but once I tighten the linkage up a little bit, then I have it all back again.
Not gonna argue, but
Yeah, that's
one thing has nothing to do with the other.
regardless,
Because the fuel shuts off at the injection pump, it has nothing to do with the controls.
The gentleman's comment over here on this sailboat, putting it in reverse, folding prop.
Mhm.
Was there a service bulletin that came out where Yanmar says don't leave it in reverse? Is that true?
Yes, some of them were getting the ones with the clutch cones would get locked into reverse. And so when you actually try to put it back into neutral, you couldn't because it literally was locked in. And when that problem first happened, people were pulling transmissions out and sending them back to the distributor. And all you really need to do is, while trying to lightly put it back to neutral, you bump the starter, and that jars it, which then pops it back into neutral.
The Yanmar service book, and there's so many variations, if you have scale drives or not, if you have SD60s or SD50s, is it a hydraulic or a mechanical? There's a lot of variations. It's not a one solution fits all, and even Max Pop's guidance says that, it really depends on the transmission
Right.
and that, so I think there's a lot of old wives' tales about never put it in or not. One thing that is clear though is don't ever start it if you're like in full reverse, which I've seen lots of people, these they forget. If I raise sailboats and all of a sudden, you know, they're feathered, you gotta start on short notice, they start, all of a sudden, whoa, that's good.
Is there a question? I thought it's Steve, yeah. Yeah. Any last questions? You're welcome.
All right, guys. Well, that concludes our presentation today. Everybody, thank you. Give Scott a round of applause. All right, guys. Next seminar we have is February 8th. That's going to be with Lenny Rudo of Fish Talk Magazine. Is actually going to be here doing a 2-hour presentation on fishing on the bay. So that should be pretty interesting. So check the newsletters and sign up for that, guys. All right. Well, thank you all for coming today.
Well, there's one at the very bottom of your heat exchanger tank. There's one there. Right.